Hello, this is Mr. Precella, and today I thought we'd do something fun. Why don't we work the Test 2 review for my college algebra class? And we'll start with number 1. Well, let me write the problem down. Oh, that pen is no good. That's a huge one. Test 2 review. It starts with circles. Number 1. It says find the center radius form of the equation of a circle with center at 4, -2, and the radius is equal to 5. Once we find this equation, they want us to draw a graph using the circle graphing tool. So let me switch over. There. Test 2 review. And we know center radius form for the equation of a circle. It's x minus h quantity squared plus y minus k quantity squared equals the radius squared. So remember, h is the x coordinate of the center, k is the y coordinate of the center, and well, obvious, I've labeled the radius with the letter r, so r is obviously 5. So we have x minus, we have y minus. Here we put the 4. After the y minus, we have a -2. And as I said, the radius is 5, so we have a 5 squared. We can clean this up a little bit. It'll be x minus 4 quantity squared plus, now the y minus the -2, that's a y plus 2 quantity squared equals 5 squared is 25. So there's my center radius form that I have to type into my lab. So we come over here, and I need to blow that up there. That's better. So we have, let me see. Hold on. Nope. I think that looks a little better, don't you? Now I can see where I'm typing. So I type my left parentheses, x minus 4, close parentheses. I use my exponent hot button in the toolbar. Right arrow to get out of the exponent position, plus left parentheses, y plus 2, close the parentheses, there's the square, get out of the exponent, equals 25. Okay, now we want to draw the graph. Okay, I'm going to click right here to enlarge the graph. First thing you do, you have to know that you're graphing a circle. So you click the circle graphing tool right here. Notice if you hover over it, it says circle tool. And then it wants you to plot the center. Well, the center was at 4, -2. And notice it says the center in the upper right hand corner of that yellow box, 4, -2. That's where my cursor is. Now they want us to plot another point. Well, we know the radius is 5, so count 5 units in any direction. I think I'll count 5 units to the right. We're at 4, so we're going to move 5 units to the right. That'll be at 9. There, we counted 5 units to the right. When we did that, notice you also went 5 units up, 5 units to the left, and 5 units down. Save it. And let me move this little timer there. Check answer. Number 2, oh, it's another circle problem. Notice here they give you the equation in center radius form, and all they want us to do is draw the graph. Let me write this problem down. X plus 3 quantity squared plus y plus 4 quantity squared is equal to 4. Notice something. When we're looking here, what you see inside the parentheses is exactly the opposite of the center. Remember, center radius form already has those minuses in there. So you had a center of 4, but what you see in the parentheses is a minus 4. We had a y-coordinate of the center of negative 2. What you see is a positive 2. So what you see in the parentheses is exactly the opposite of the center. So in applying that logic here, our center would be, it's exactly the opposite of a plus 3, so a negative 3. The y-coordinate, the opposite of positive 4, is a negative 4. Now the radius. Realize what you see here when you're looking at center radius form, that's not the radius. To go back to the actual radius, you have to undo that squaring, which means you have to do what? Take the square root. So the square root of 4 is equal to 2. So our center is at negative 3, negative 4. Our radius is at positive 2. Now that we've written that down, let's go back and graph it using the graphing tool. That's all they want here. Just draw the graph. There. Click the circle tool again. If you hover over it, it says circle. And it says plot the center. Our center was negative 3, negative 4. And then what was the radius? 2 units. Well, let's move up 2. 1, 2. We started at negative 3, negative 4. We moved up 2 units. We could just as easily have moved 2 units to the right, left, up, or down. It would have gotten the same picture. You save it. Check answer. And we're done with that. Number 3. Oh, look here. And number 2, they give you the equation in center radius form. But realize in number 3, they've gone through, they've FOILed out the x plus 3 squared. They FOILed out that y plus 4 squared and combined like terms. This is called expanded form or general form. We want to find the center and radius of the circle with the given equation, and then we draw the graph. Well, to find the center radius form, to find the center and the radius, we're going to have to write the equation in center radius form. Let me write this down right now first. X squared plus y squared plus 4x minus 2y is equal to 44. So let me switch over to my paper. There. We are trying to get this equation written in center radius form. Remember what we said to do. This process is called completing the square, creating perfect square trinomials that'll factor as a binomial squared with x and a binomial squared with y. What I said to do was to first of all verify that the leading coefficient is a 1. If there were anything other than a 1 there on the x squared or y squared terms, we'd have to divide 3 by that. Fortunately, it's already a 1. Next, I'd group the x terms together. X squared plus 4x plus, I'd skip some space because I'm trying to create a perfect square trinomial. Then I group the y's together. Y squared minus 2y plus, skip some space. I already have a 44 on the right. Do y'all remember the process? There were two things we would do. We'd take the coefficient of x. First thing we do, we divide it by 2. That would give us a 2. Then we would square that 2. 2 squared is 4, and 4 is what goes in that block. But you can't add just 4 to one side of an equation without adding it to the other side. You have to maintain that balance. So add a 4 there as well. We'll factor the x terms in a minute. Apply the same logic to the y terms. It's hard to read that. That's a y squared minus 2y. You take that 2. Realize you're going to be squaring the result, so the number you add is always going to be positive. So I don't worry about that negative sign. I just take the 2, divide it by 2 to give me 1, and then I square 1. 1 times 1 is still 1. So I put a 1 here, and I put a 1 there. The x terms factor very nicely. When you're factoring a perfect square trinomial, it'll factor in the form variable sine half of that number. So x, and then the sign you put is that sign that connects the x squared and the 4x. So variable sine is a plus. Half of that number, half of 4, is 2. So if you took x plus 2 times x plus 2 and FOILed it out, you'd get x squared plus 4x plus 4. Apply the same logic to the y terms. It's variable y sine, that's a minus, half of 2. 2 divided by 2 is 1. If you take y minus 1 times y minus 1 and FOIL it out, you're going to get y squared minus 2y plus 1. On the right-hand side, you have 44 plus 5, which is 49. So now, number 3, finding the center and radius, it looks like number 2. Since center radius form, you just change sign, take the square root. So to find the center, change sign, the x-coordinate is a negative 2. Change sign, the y-coordinate is a positive 1. To get the radius, you take the square root of 49, which is 7. That's what we need in order to draw the graph. So let's go to MyLab. We need the center and the radius. Let's type in the answer. Let's see. Oh, well, they don't even want us to type in the center and radius. All they want us to do is draw the graph. Well, you got to know the center and radius to draw the graph of the circle. The center was negative 2, 1. Notice, no, it's negative 2, positive 1. Notice they're incrementing in units of 2. Each one of those cross lines is a unit of 2. So look up there in the upper right-hand corner, right here, where it's showing the coordinates to make sure you've got the cursor at the correct spot for the center, negative 2, 1. And then our radius is 7. So we got to move, I'm going to move up 7. We're starting at a y value of 1. 1 plus 7 should drop us at 8. Let's see. 1, 2, 3, 4, 5, 6, 7. There's the secondary point. Just counted 7 units up. Save. Check answer. Any questions? Well, I bet you number 4 is another one like, no it isn't. Okay, only one circle here. That's fine. So, I mean, only one completing the square. Let me write this problem down. This is number 4. Find the domain of the following function. Do not use a graphing calculator. Our function is f of x equals 1 over x squared minus x minus 6. Okay, let me switch to my paper. There. Let me do something else. No, I'll make it like that. There. Okay. When I'm trying to determine the domain, the first thing I do is ask myself, will the function produce imaginary numbers? And the answer is no, because there are no square roots. Then I ask myself, will there be any undefined results? Yes, this is a fraction. When is a fraction undefined? Remember what I said, n over o. That says no, you can't have that 0 in the denominator. So x squared minus x minus 6 cannot equal 0. That's quadratic. We can factor it. We're going to solve it as if it were an equation rather than a not equal to situation. X squared, x times x. If the second sign's a minus, we have one of each sign. So we have a plus and a minus. For 6, I think if we put the 3 there and the 2 there, notice, if you're checking, first is x squared. Here's my checking. It's my scratch word. Outer is a minus 3x. Inner is a plus 2x. Last is a minus 6. Negative 3x plus 2x. Sure enough, that's just a minus x. This is the correct factorization. So x plus 2 can't equal 0. And x minus 3 can't equal 0. That means x cannot equal negative 2. Moving that negative 3 over, x can't equal positive 3. So the domain, we're saying that x can be anything except negative 2 or positive 3. Could x be 50 million? Yes, it can be 50 million. You can plug in 50 million for x, but the only two numbers you can't use are negative 2 and positive 3. So if I were going to write it out in words, I'd say all real numbers except negative 2 or positive 3. But that's not how my lab wants it. They want you to give it to the domain in interval notation. So, negative 2, positive 3. Think of a number line. You can't have negative 2. You can't have positive 3. Those are like those denominator cut points with the cut point method. You always label them with open circles. You could have anything over here. Okay. You could have anything between negative 2 and positive 3. You could have anything to the right of positive 3. The only numbers that are being excluded are negative 2 and positive 3. So writing that using interval notation, parentheses, negative infinity, comma, negative 2. Notice there are no closed circles. So there are no rectangular brackets in the interval notation. The only symbols you'll start and end with are parentheses. So parentheses, negative 2 to positive 3, union, parentheses, 3 to infinity. So, okay, got to go type that into my lab. I have my paper here. I'll be looking at that as I type it in. Parentheses, negative infinity, comma, negative 2, right parentheses, union, left parentheses, negative 2, comma, 3, right parentheses, union, 3, comma, infinity, right parentheses, check answer. Any questions there? I think I'll blow the screen up a little more there. Okay. Number 5. Let me write it down. It's another domain problem. Find the domain of the function. This is number 5. Come on in. I'm working out the review to the second test to put it on our YouTube channel for students that are reviewing for test 2. So, once again, they want us to find the domain. And let me switch back to my let me switch back to my paper right here. There. The first thing when I'm finding a domain, I always ask myself, will the function produce imaginary numbers? And in this case, it will. I see that square root. I don't want the thing under the radical to be negative. If I plugged in something for x and it gave me a negative y value, say I plugged in 5. 8 minus 20, that'd be a negative number. So what I want is the 8 minus 4x to be greater than or equal to 0. The thing under there can be 0. The square root of 0 is a real number. It's 0. So there's nothing wrong with the expression under the radical equaling 0, but it needs to be greater than 0. And when I'm solving inequalities like this, I always use the cut point method. So first thing I do with the cut point method, I ask myself, when is 8 minus 4x equal to 0? That's when negative 4x is equal to negative 8. Dividing by negative 4, we get a solution cut point of positive 2. We ask ourselves about denominator cut points. Well, there are no denominators here. Notice this thing is never undefined, so there are no denominator cut points. We draw a number line. 2 is the only number on the number line. And remember, for solution cut points, you look back at the original inequality. Equalities allowed. So we have a closed circle. Now, which side of 2 will have a result that's greater than 0? Well, to make the decision, we test a number on each side. Say here, if I were to test 0, if I were to test 0, I could use 1, I could use negative 50 million. Any number to the left of 2 is a suitable test value. There's infinity and there's negative infinity. Testing 0, I get 8 minus 4 times 0 is greater than or equal to 0. Well, we know the order of operations. You multiply first, so 4 times 0 is 0. 8 minus 0, is that bigger than 0? Yes, it is. So we shade that interval. Since this is a linear expression, no even exponents appear, and I'm 100% confident that this interval will turn out to be false. But let's just test a number over here just to illustrate what I mean by that. A number to the right of 2. I could test 3. So we have 8 minus 4 times 3. Is that greater than or equal to 0? So 8 minus 12, is that bigger than 0? Is negative 4 bigger than 0? Say no. No, okay. Cross that out. And the domain is the shaded interval. Parentheses, negative infinity, comma 2. There's a bracket and a closed circle, so bracket. So we come over here. That's the domain we're looking for. Parentheses, negative infinity, comma 2. And remember, the bracket comes from the keyboard. It's not down here in the toolbar. Bracket, check answer. And any questions there?